Okay, this is chapter 3.3, properties of logs. So because a log is a lot like exponents, it's basically exponents in reverse, there is an exponential property and then there's a kind of a corresponding log property that goes with it. So I'm going to describe these in terms of the exponential property. I'm going to show you a log property, then I'll give you an example. So the first log property, if you ever have like bases, what your rule is you're supposed to add up the exponents. What that looks like in logs is log base A of u times v. These two are multiplications and you have the same base. So here I have log with multiplication, and what you can do is you can split that up into log base A of u plus log base A of v. You can turn multiplication and you can split it up into addition. So an example of that would be like log base 8 of 64x. That's multiplication, so I can change it to log base 8 of 64 times, or plus log base 8 of x. And log base 8 of 64 is 2, so I can simplify it down to 2 plus log base 8 of x. Division, when the bases are alike, you're supposed to subtract the exponents. It works the same when you have division within a log. So it's log base A of u divided by v can turn into log base A of u minus log base A of v. An example would be like log base 9 of x over 729. I can rewrite this as log base 9 of x minus log base 9 of 729. Division can be rewritten as subtraction, which can be turned into log base 9 of x minus 9 to what power is 729. 9 times 9 is 81 times 9 is 729, so it's 3. Log base A of u to the v power. The rule when you went power to power was you're supposed to multiply. This is slightly different on this one. Log base A of u raised to the v power. You're going to write it as multiplication, but what you're going to do is you're going to take that exponent and you're going to pull it out in front and write it as multiplication. So it becomes v log base A of u. Exponents pull out in front of the log, written as multiplication. Usually don't write the time sign there, but it's there. So it's log base 4 of 64 to the 10th power. The rule is I can take that, I can pull it out in front. 10 log base 4 of 64. 10 log base 4 of 64 says 4 to what power is 64? It's 3. And I could rewrite that as 30. So one thing you usually have to do when you do these log exponential properties, these log properties, is it's going to ask you to expand or condense. So I'm going to do the expand first. Expand means all of this here, I'm going to take it apart and I'm going to expand it out with basically with the properties that we just went over it. So ln of xyz squared, this is all multiply. I can rewrite as the ln of x. Multiply can turn to addition. And again, multiply turns to addition, except I'm going to take that 2 and I'm going to pull it out in front for the z part. So it'll be 2 ln of z. Multiply, addition, exponent out in front. Here's division. This is going to turn into log base 5 of 3 minus parentheses, because I want to subtract it all, minus log base 5 of x plus 5 out in front, 5 log base 5 of y. And that parentheses means I'm going to keep all of that together on the bottom, and the division turned into the minus sign. Here's kind of a weird one. I'm going to turn, this is supposed to be log base 2, so I'm going to turn this into log base 2, and I'm actually going to rewrite the square root as x to the x minus 1 to the 1/2 power over 9. So now I can rewrite this as out in front, 1/2 log base 2 of x minus 1, and then division is minus, so it's minus log base 2 of 9. And as you can see, all three of those, they got bigger, they expanded out. And you might be able to evaluate some of these pieces, individual pieces, but the idea is that you can pull it apart. Condense means to crunch it back together. So what we're going to do is we're going to take these and we're going to try to shrink them down. And it only works if the logs are the same. And you can see that I set all these up so they're all logs that are same. These are all log 4s, those are all log 6s, these are all ln's. So that has to be true in order for you to do this. So I'm going to rewrite this as the ln. That goes back to an exponent now. 8 squared minus ln of 4. And minus means division. So I'm going to rewrite this as the ln of 64 over 4. I evaluated that, and then I rewrote as division, and 64 over 4 is 16, so you could rewrite this as the ln of 16. Alright, I see a bunch of pluses, so I'm going to write it as multiplication. It'll be log base 6 exponent, x to the 1/3 power, y exponent, z to the 3rd power. And the last one, this half is going to go with all of this, so it's going to be log base 4 of x plus 1. That number is going to become an exponent, x minus 1 to the 2nd power, and now that half is going to go around it all. And I still have plus 6 log base 4 of x. So that plus sign means it was going to be multiply. I took that 2 and I wrote it as an exponent. Now I'm going to deal with the half. The half's going to go with both of them. So it's going to be log base 4. Well, x plus 1 to the 1/2 power is the same as the square root of x plus 1. Don't forget, fractional exponents can be written as radicals. Times x minus 1 squared to the 1/2 power will just be x minus 1. Now I see another plus here. I should have probably kicked that up into the exponent spot right from here. So I'm going to rewrite that as x to the 6th, and because of the plus sign, I'm going to tack it on as multiplication. So condensed down, that would be your answer.